viewers, welcome to MR.Wanyoike, the digital learning platform. In front of you is Mr.Wanyoike himself, a mathematics teacher. In today's lesson, we are on continuation of probability, and in today we are going to look at combined event where the concept of replacement is applied. And as far as the first example one here, there is a bucket containing 2 blue pens and 3 black pens. The pens are identical except for colors. 2 pens are picked from the bucket, each at a time with replacement. Find the following probabilities. Number 1, first pen picked is blue, and B, Roman 1, first 2 pens picked are blue. Roman 2, at least 1 blue pen is picked, and Roman 3, at most 1 blue pen is picked. And lastly, but not the least, picking 2 pens of different colors. And as far as this question is concerned, there is a concept of tree diagram which is very vital, and you're supposed to apply this concept so that it can help you in addressing the questions. And how do we experiment it practically? And therefore I am going to do it practically. I have a bucket. There is a bucket here, and also in this bucket we have 5 pens. We have 5 pens. This is the black one. Remember, there is nothing inside. I put it inside. That is 1. Then the other black, I put it. Then the third black, I put it. Then the first blue, I put it. And the second blue, I put it too. So when I'm going to make a tree diagram, I'm supposed to make a tree diagram. I'm supposed to make. Let me construct one here. I'm supposed to use a tree diagram like that, and here I have a key. I can come up with a key here, and this refer to blue. This refer to blue, and this, the other one, this one, the second one here refers to black. And here I have a blue and I have a black. Black is the one which is having applying. Then also this here, I have a black, I have a blue, I have a black. The same case applies. I have a blue and I have a black. So black is this one. Black are these ones which I put applying there. And what is the probability of picking? You can see that inside this bucket, I have 2 pens which are having a lid which is blue, and the other are having a lid or a top which is black. And therefore, I have, when I'm coming to pick for the first time, for example, if I pick a blue one, I will get 2 blues. At first, when I'm coming to pick for the first time, I will get that the number of blues are 2. 2 pens, 2 blue pens are 2. And therefore, the probability of picking a blue pen should be 2 out of 5. Why? Because the black pens are 3. And therefore, I'm supposed to write the probability of picking a blue being 2 out of 5. 2 out of 5. What about the probability of picking a black one? The probability of picking a black one is 3 out of 5, because I illustrated very well that there were 5. Assuming that after picking, I picked, after picking, then that is the first picking. Then before I pick, what if I did not pick the blue one? Meaning that if during the first picking I picked a blue, it might be also the black one. Instead of picking the blue one in the first picking, I might have also picked the black. So meaning that whenever I'm coming to pick the black one, I will get the black pens being 3. And therefore, because the total number was 3, I'm supposed to write 3 out of 5. What about during the second picking? After I picked the pen, I'm supposed to replace in the pen inside before I pick for the second time. Meaning that by replacing, I maintain the original total number of outcomes. That is the original total number of outcomes, which is supposed to be 5. I should maintain it by making sure that the first pen which I picked during the first picking, I return it before picking for the second time, and therefore it means that the values are 2/5 and 3/5 remains as a constant, and therefore it means that if I'm coming to pick for the second time, similarly I will get 3 black pens and also 2 blue pens, and therefore the probability of picking a blue during the second picking, it should be for la blue it is 2/5 because I replaced. Then likewise for the black, likewise for the blue, and also for the black, and therefore these probabilities remain the same case. So because the first one represents first picking, this is first picking, and the second is the second picking. We have second picking, so that you can end up having 2, and therefore the outcomes are here. That is the first one give us B and B, that is a blue and a blue. What about the second one? A blue and a black. What about the possible outcome for the third possible outcome? There is a black first picking and the second picking blue, and finally 2 black. 2 black, you can see the black is represented by that symbol which is also accompanies B. And having come with this tree diagram, I'm supposed to go back to the question, and question Roman 1, that is question A. As far as question A is the probability of picking a blue pen. The probability of picking a blue pen. The probability of picking a blue pen should be 2/5, and therefore I write 2/5. And what about the second part of the question? As far as B Roman 1 is concerned, first 2 pens picked are blue, and therefore what is the probability of getting a blue and another blue? And therefore from the diagram here, you can see that a blue and a blue, the probability, you're supposed, whenever you're moving across, you are supposed to multiply, and therefore you are supposed to say it is 2/5, this one. You multiply by 2/5 because it's the one which is giving us B and B, and therefore you're supposed to multiply by 2/5, and therefore the answer becomes 4/25. That is the answer as far as the probability of picking 2 pens which are blue. The third question is the probability Roman 2, at least 1 blue pen. The probability of picking at least 1 blue pen. So what is the probability of picking at least 1? You can see that the only results are this. At least means where there is a blue. You can see here there is a blue, there is a black. At least where there is 1 blue. Also there is this one. That is also an answer, another answer. And also the word at least means that it should be at least 1 or more than 1. It means that even this is also another result. And it means that the answer will be given by the outcome BB plus the probability of outcome B black, then plus the probability of black and blue. And therefore, what is the answer? The probability of at least BB is given by the value here. We have already calculated it here. So, should be 2/5 times 2/5. You can see B and B. 2/5 times 2/5. Then, the other one is blue and black. This is blue and black. It is given by 2/5. You multiply by 3/5. And finally, the probability of black and blue. Black and blue is this one. So you start with 3/5. You multiply by 2/5. 2/5. And this becomes, once you multiply, you get 4/25. and the other one you will get 6 over 25. The other one you get as also 6 over 25. And what is that? The LCM is 25. The first case you will get 4 plus 6 plus 6, and the answer becomes 16 over 25. That becomes the answer to our question. That becomes the answer to our question. So you can see that as far as that question is concerned, that is a question as far as probability, where there is with replacement is concerned. That is how you are supposed to reason. So you can see that in the first part of the question, I have come up with a tree diagram. And in my tree diagram, we have two possible outcomes. You either pick a blue or a black. And the probability of picking a blue is 2 over 5. Why? Because there are 2 blue pens and there are 3 black pens. And therefore, the total possible outcomes is supposed to be 5. Why? Because 3 black pens, those are, as far as the black pens are concerned, we have 3 outcomes. And also, as far as the blue is concerned, we have 2. And therefore, 2 plus 3, you will get 5. And therefore, the denominator is, in this case, becomes 5. And for the second picking, the values do not change. Why? Because there was replacement of the first pen which was picked, and therefore the original number of pens in the bucket in each and every picking is constant. The original number of pens as far as each and every picking is concerned, the first picking, the second picking is constant, and that is 5. The original number is maintained to be 5 pens in the bucket each and every time you pick. And what about the number as far as colors of the pen is concerned? It also remains constant, because at every picking time you will be there will be 2 pens which are blue, and also there will be 3 pens which will be black. Having said that, your presenter was Mr. Wanyoike. Your presenter was Mr. Wanyoike, and you can reach me using on the YouTube, you search me using the name Mr. Wanyoike. You will get me for more inquiry. Till next lesson, bye bye.